to discuss how to change between standard canonical forms of a function and how we can acquire the f bar or the inverted version of the same function. So assume we have f of x, y, z, and w, which is equals to sum of minimum terms 0, 1, 3, 8, 9, and 14. 0, 1, 3, 8, 9, and 14. Now we have 4 inputs. So 4 inputs. Therefore, we have 2 to the power of 4 equals 16 different combinations of inputs. So we are going to have minimum terms from 0 to minimum term 15 and maximum term 0 to maximum term 50. Now if the function is sum of minimum terms 0, 1, 3, 8, 9, 14, it is also equal to product of maximum term with this range. So we start from 0. If we have the number in as a minimum term, which means the function is 1 for that specific combination of inputs, so it has to be so it is 1. If it's not in this list, then it means that we have a 0 for that combination of the inputs. Now I start from 0 and go to 15. Product of maximum terms of these numbers. 0 is here, 1 is here, then 2, 3 is here, then 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is here, then 15. And we are going to stop just right here because our indexes related to the input, the combination of inputs is from 0 to 50. Now if you want to find for f bar equation, the canonical standard equation for f bar, standard canonical equation, or we can say implementation. So it is going to be, now let me change the color. Now if you check, so if function f is 1 for this list, this combination of inputs, and 0 for this combination of input, it means that, so here f is 1 for this combination of inputs, so it is going to be 0. So f bar is going to be 0 for the same combination of inputs. So this is going to be product of maximum term 0, 1, 3, 8, 9, 14. So if F is 0 for this combination of inputs, then F bar is going to be 1 for the same combination of inputs. So sum of minimum terms 2, 4, 5, 6, 7, 10, 11, 12, 13, and 15. Just another reminder. We can define any function based on the zeros in the output or based on the ones in the output. Sum of minimum terms is going to define the function based on the ones. So it is telling you that the function is 1 only for this combination of input. So if the f is 1 for this combination of input, then f bar is going to be 0 for this combination of input. And when you define based on zeros, when you define a function based on the zeros, then you have to implement the function using product of maximum terms. The same thing you are going to see in here. So if a function is defined based on the zeros, it is telling you that for this combination of inputs, the output is going to be 0. So if f is 0 for this combination of inputs, then f bar is going to be 1 for the same combination of inputs.